Hello, everybody. I'm here to talk a little about what we do in IBM with Node. My name is Dejan Glozic, and I come from IBM Canada, from the Toronto lab. This is my this is my Twitter handle, and I write about everything we do on dejanglozic.com. It's my blog. I call myself a full-stack architect, which is kind of almost like a joke that I came up with a few months ago. I figured if they're a full-stack developer, there must be architects. And I started putting that on my IBM internal page, and nobody complained. Then I printed business cards with that, and nobody complained. So it seems like IBM letting me, so I'm going with it. I've been working on cloud apps and essentially writing small applications in the cloud for the last 2 years. And more recently, we started doing it in Node and with microservices. It's just a little disclaimer. IBM is so big that I only talk about my little corner. There's other teams doing interesting things with Node, but I only talk about what we do in IBM Rational. I'm working on a project called IBM DevOps Services, which is kind of a dry way of saying what we called before, which was a Jazz Hub. It is essentially a development environment in the cloud for the cloud. You can code the entire app, track it, you can deploy it into your target environment. And so recently we started coupling it really closely with IBM Platform as a Service called Bluemix. Which is that's IDS, just a screenshot made this morning. And Bluemix is platform as a service that that IBM built on top of Cloud Foundry. So if you use any of your Cloud Foundry tools or code, it'll work. You can have build packs that work with it. So in that context, we originally built IBM DevOps Services IDS very quickly as an experiment. And as all experiments go, it was put together kind of hastily and with little regard for architecture. And very soon it became kind of full of how we call it technical debt. Not very sort of nice way of building something. So we set out to build something more substantial, so evolve it in mid-flight. And we decided to do it using microservices and using Node. So how we came out to do both of those decisions. When I was thinking about our story in general, I realized it's not really very unique. So I was thinking about other patterns, other sort of cliches, and this came to mind, essentially, the kind of classic romantic comedy. A boy meets girl, loses, and then recovers through love. So what would the pattern that I'm trying to sort of to explain to you look like? The new cliche, it would be, so a boy builds a monolith quickly, puts together something just to show the value, and then, it's a success. So let's add lots of new features, and then before you know it, it's just big, horrible thing that is just falling apart from its own weight. And then you say, okay, that's it, we have to rewrite it. Let's write it in a lot of small services, and more often than not, they are Node, actually. Once you're doing it, why not use something cool? And as a last point, you just go and just talk about it everywhere. So before microservices, as Richard mentioned, there were other names for that. And in 2012, Adam Wiggins from Heroku, co-founder of Heroku, came up with the 12-factor apps. I call it the Church of 12 Factors because it has, those factors are written as commandments. Thou shalt not keep your configuration with your code in source control, for example. And we really liked them and started applying them. That was really just one leg of this entire approach because it told you, it had great tips of how to build the small apps in the cloud. So that's explained how. But more recently, there was some work on sort of in coming up with the whys and a reactive manifesto, if you heard about it, sort of it puts together 4 tenets of how to build reactive systems in the cloud. They need to be reactive to events, reactive to load, reactive to failure, and eventually reactive to users. So 4 tenets. And then once you sort of put that together and say, I'm building a microservice system, now you have a what you're building. So, or if opera-friendly concept 1.4.12. You're building microservices because you want the system to be reactive. And how are you doing it? You're doing it using applying 12 factors. So I think we got our theory sort of down, and then we had to figure out what technology we're going to use to evolve our ball of mud into something more, something better. And we decided to not be easy on Node. We sort of make it work for it a little. Not because we need to convince our bosses, as Felix Dussendorfer, I think is his name. The former Node core maintainer said that he had like an article, how to convince your boss to use Node. We didn't have to convince anybody. I'm high enough in IBM that I need to convince myself, actually, and just say, you're the expert, you figure it out. And if it doesn't work, we'll fire you. So no pressure. So I had to convince myself that Node is the right thing. And I really did a lot of sitting on the fence, essentially. I actually wrote an article called Sitting on the Node.js Fence with these graphics. And this is what I did this for the most of the 2013, just going back and forth on whether Node is ready and the right technology for what we wanted to do. But then at the end of 2014, there was kind of a flood of talks, announcements. There was the Walmart leak, there was the plugging of the said leak, Walmart, sort of Groupon, PayPal, Yahoo, they all came out with their success stories of how they ported to Node and lived to tell. So I figured this is an inflection point. It's time we can start going into it. So we could go, as Bill Scott from PayPal would say, get the proverbial camel's node into the tent. So what to do? Which service to pick to be the first one? And we were thinking, what would be unique about it that would make it better for Node than any other technology? And we figured it should be something that is really dynamic, something where you cannot poll, something that has to use server push, WebSockets. And this is a screenshot I made on Thursday because coming here. This is part of DevOps, IBM DevOps services. This is the development pipeline. So this page is working today. We set out to build this in January, and this page is written in Node. It uses Dust for rendering, uses Node, uses a bunch of, like your alphabet soup of Node modules. But the reason that we thought that this service, when we were building it, before we built it, is a good candidate is because I think I counted, there are like 25 of things on the page that can independently change as a result of some moving part changing state on the server. And we said there's no way that we're going to poll for each of those. We need server push, we need WebSockets. What is working really well, WebSockets? Node. That's sort of one-on-one. The school sort of example of a Node application is a dynamic application that uses WebSockets to push stuff from the server. So as I flip between sort of two screenshots I made within a few seconds, a lot of things keep changing. Builds are starting and stopping. Deployments are happening. Applications are running and not running. And all those things are pushed through WebSockets. So we had that one app, and that was fine. It was a success. And we said, fine, let's go. Let's build more. And there's a lot of people building one app. Once you want to build two, you need an architecture. You need the way that those applications are going to work together. And we needed a way, some sort of key points of how we're going to put this whole system together. Otherwise, we'll make many little balls of mud that sort of go together into one big ball. So we set out to put forward kind of key tenets. How are we going to do things? We want to build, obviously, many microservices. We don't want to build a monolith again. Second, we want to deploy those services independently. We have a number of teams working on them. We don't want them to all have to go together. We want them, each team to deploy and maintain and be responsible for the service independently as sort of, march to their own drummer. We want, of course, from the very beginning, we set out and said those services will use message queue. We jumped ahead to the sort of this bigger sort of fancy architecture as Richard put together, put forward, and skip just REST communication between them. And eventually we decided We don't want to. We want to make clustering decisions locally, service by service basis. Whichever service needs more support, needs to be sort of scaled out. We will do it on a service by service basis. So our first tenet, I'll more on that. I come from IBM. We know monoliths. We've built really large applications for big enterprise customers. So when you're building something for people that are going to maintain and configure your application, you want to help them out by giving them one thing to do. You don't want to say, here, 100 services, go stand them up and hook them up and do stuff. So you give them one thing, it's essentially a master on-premise. Once we became responsible for our own system, everything changed. And I like to call that this is like a bizarre world of on-premise, is that everything that is good on-premise is sort of bad. It's really bad for us to have one monolithic service and to be responsible for it. We want a lot of simple ones, and they can, as I said, evolve and deploy at our own pace. And so we decided we're going to break the system into manageable chunks. And while we're doing it, let's use Node. And we already have experience with the pipeline, so let's keep applying all the good experiences from it to all the other services. So we came up with something like this. I don't expect you to but I put this forward and plastered it on all the walls and said, we are walking towards this. We're not nearly there yet. There's a lot of things that we didn't build yet, but this is our North Star. We're marching towards it. We have a master plan, and then every month we keep standing up more and more services that actually make this more a reality. But we put a load balancer in front. There's a bunch of all the columns essentially have features that give some unique features to the site. And web services serve pages, API services are APIs, and they'll proxy so that you can hit the API with a nice URL from, and it all looks like one system. There's a lot of backend services. We use a lot of applications we stood up in IIS, Jenkins, Urban Code Deploy, that's IBM's sort of deployment tool. We use Docker, we use Git. So all those things are also services, just not micro, but act as URLs you can hit. And we use NoSQL databases. We use CloudEnd because it's convenient. We bought it. It's essentially a hosted CouchDB with some secret sauce on it. So, and then there's glue services. Something already talked about composition. We have to do the same thing. There's a composition service that sort of serves things that are common between the pages. We are evolving it still. It's a hard problem, so we got to a point, but we keep going. We collect activities. I have a service that will give you sort of activity feeds of the entire system and kind of like using activity standard, actually. We keep your usage of all the services for the purpose of charging you for metering. And everything is served by a there's a broker that passes the events between all the services, and we log everything. So that's, in a nutshell, sort of where we are moving, and we are in the midst of it. We're not done. So this is not like a rearview mirror talk. This is, we're doing that. We found that Node is great for building small services because even the symbol of Node is kind of, you want to put a lot of those together into a beehive rather than just have a single solitary Node service running. And it's almost like you need to work really hard to make a big monolithic service in Node. It's kind of almost like a Node has antibodies for that. It resists you. It quickly becomes unmanageable if you try to do it even. So you don't even attempt. So Node is a great kind of, we discovered, because it's misery on the resources, because we have to stand up all the others. We're in the middle of this transition. So there are Java services running and monolithic. So when we compare our system usage, we are always shocked as how little CPU and RAM is used by a typical Node service. It's, of course, I want to talk about sort of component model and NPM, how it helped us find everything we wanted to write ourselves. So a standing order, please go search NPM before writing your own utility. Somebody already, or 5 people wrote it probably. It has great build and test tools available to you. it's easy to write for us. We have a lot of experience writing client-side JavaScript, so for us it was not hard to find candidates and convince them they were easy to come by. Deploying independently, it was really a must because we had this sort of big systems. We had to have like a deployment windows where you're just out of service. You say we are currently maintaining, so do something on a Saturday night or something, which makes no sense today, around the clock world. So we have no budget for outages. Essentially, we need to sort of involve the system in mid-flight. So Node is great. It's a great candidate for that because Node services start and stop in seconds, and we feel smug when our colleagues who still need to sort of wrestle with Java, they do that. They're really happy when do it in minutes, and we come and up and down, and we want to go to 0, but if you just restart one to pick up changes, it's really in seconds, and we are using PM2 for that right now because we are running in soft layer, which is IIS, so we need to kind of take care of our own clustering of instances for scaling up on the same VM. We build the services to be pass-friendly, which means at any point we can decide to run them in a pass. We use Bloomix for that as a Cloud Foundry, essentially, but we find that it gives us more options, essentially. We don't have to run them in a VM if we don't want to. PM has an interesting facility where if you run a number of workers, when it restarts them one by one. So there's always a service, always an instance that is serving something. So you can even go to like a cheap ass zero downtime deployment if you want to. When it comes to message brokers, we set out to use them from day one because we decided that we are not going to have 50 services just keep asking each other, are we there yet? Are we there yet? So they're just polling crazily. You don't want a chatted system. So a good rule of thumb was when you have paranoid ops, essentially, each VMs come out of the box completely locked down. You cannot make any outbound requests, so you have to put a firewall rule for every request. And just go and look at your list. If you have a lot of entries in your firewall, your service is very chatty. I mean, it's talking to a lot of services directly, as opposed to just hooking up to the message broker and receiving its state from there. So wherever we can, excuse me, we are using event collaboration pattern where we are receiving state changes through events rather than going straight for a service to ask for it. And the advantages of using the broker for us is that, well, we cut down on unnecessary chatter. Every time you ask and the state didn't change, that was a wasted call. Brokers add a little bit of resiliency because you fire a message and then you can forget, and you don't have to, whether the other party is up or not doesn't matter. And then they add a bit of safety valve in that they can serve as a sort of pressure. They can take a little bit of traffic while the services on the other end recover. So it can sort of hold on the messages until they're ready. It allows you to loosely couple your services so that you don't have to know what you're going to have in the system. A service that fires a message doesn't have to know who's listening. And you can add another one, listen to that topic later. You don't have to update the service that fires. So here's it now enables service push. Once you hook up your broker through WebSockets to the browser, you get server push as the last mile of that communication. So here's an example of how we would use it. You can, in a browser, you can press a button to start a build. It posts a request to the Node app that turns around and sort of conveys that request to a backend app. The backend app will start running a build. As the build is going, it fires events through its life cycle. I started, I'm at 30%, I'm 60, I'm at 90, I'm completed, I succeeded. All these events are picked up by the Node service that packages them and sends them back to the client, and this progress will keep moving. So that's a very simplified example. That's from one of my articles. So Node turned out to be a great candidate for that as well. We have support for both for a number of protocols, including MQTT, MQP as well. We had a number of libraries to sort of pick and choose from. Async processing in Node is great for messaging. That's what it is. We receive a message and react to it in a callback, which is very natural for how Node was already built. Node was the reason we started, WebSockets were the reason we started with Node to begin with, is awesome support for WebSockets, much better than what you would do in Java that we used to before. And, sorry. The fourth sort of tenet of how we approach this is that we wanted to use local clustering because load is not uniform throughout the system. There are hotspots in which this happens, and we wanted to address the following concerns. We wanted to apply extra capacity where it matters, because even when we own the systems, we want to waste. We don't want system to be idle and some other system to struggle. We wanted to evolve the system as needed, so add more capacity where needed. We had the option to sort of choose whether we want to beef up a service inside a VM or spread out between multiple VMs. So, and finally, concerns of high availability versus clustering is that whether a service needs to just be available or we want to sort of scale it up massively. So Node, again, turned out to be a great candidate for us because, and this is funny, is that a lot of people complain about single-threaded event looping, saying that's just awesome. We used to have threads in Java. But the way this really turns out to be an advantage is you start building in a share nothing mode from day one. You just don't assume any shared state. And that actually is fantastic once you want to scale across VMs, because you can use local clustering just to cover the cores in your VM if you want to. But then when you do load balancing, you don't have to do anything. You don't have to change anything. So whether you're local or sort of remotely load balanced, doesn't matter if your application is written to do it well from the beginning. So here's an example where we applied this in conjunction with messaging. So we learned, and this is a case where we wanted to use MQTT as a simple protocol because it allows sort of not have a dependency on a broker. This broke our sort of happy abstraction, because in MQTT, when you have multiple workers, they all receive a queue. So they all receive a message simultaneously. This is not what we wanted. We wanted essentially like a worker queue. So we had to go down to MQP and bind them all to one queue, and then when a message arrives, it's sent to individual workers round robin. So this is how we cluster. This is how sort of we work in the presence of clustering when we receive messages. Just to be fair, there are other people are using microservices, deploying microservices using other languages, other platforms. I've been at a meetup in Toronto where people are very high on Scala. They use Scala and Akka for that. You can use other platforms and languages for microservices, but for us, we believe that Node is still a great candidate for building microservices because we are building web applications, and Node gives you an edge because JavaScript is gravity in the browser. So for API services, Express or Happy are really good candidates, and we're happy with them for building services. We found that with NoSQL databases that run JSON, you can do JavaScript all the way down. That is also an advantage. So we find it very comfortable. So when Cloudend, for example, is using JSON through and through. And this has been said before. This is nothing new. I'm not discovering it here. But just to reiterate, is that developers are really eager to work on Node. So we didn't have any problem converting them and sort of getting them to sort of switch from Java. So a couple of more slides before I finish. There were some things that didn't quite work out well, or just we had to sort of face with. One thing is that legal team just hates us. We came to them with dozens upon dozens of modules they had to vet and they had to just sort of approve. And there was one where a lawyer came to me and asked me, does this sort of file in Socket.io, somewhere there's like a Pokemon emulator or something like that. And that file has 150 independent JavaScript libraries or something like that. And he said, like, do I need to really go and vet 150 libraries? Can you remove it? So it turns out we could with just a test file. So here's an example when they look what they need to go through and sort of vet, they just get a heart attack. Our operations people hate us as well because they're really not used to this world in which they have to stand up all these dozens and dozens of VM. One of them once asked me, before installing Node, do I need to install Java first? So they're used to WebSphere and they're used to all this big system. First of all, the number of VMs they have to configure and set up, the firewall rules they need to set up, it's a challenge, definitely. We are kind of wary of all that to the point where we get the platform as a service now, and we are seriously thinking about moving at least sections of our system to Bluemix, to Cloud Foundry, so that we don't have to worry about this. We don't have to require another VM. We just sort of keep incrementing instances for that. Single sign-on is hard. It's a challenge in a microservice system. If you want to have your system secure, it has to be authenticated well, but that sort of increases barriers between services every time you sort of hop between services. So that is making those hops transparent while maintaining security is something that is a challenge for us. Composition, again, is hard. Clifton, I don't need to reiterate, but we keep hearing about web components and how HTML imports are totally going to solve this problem, but we're still waiting for it to be a viable solution. So it still continues to be a problem. Still, we have no regrets. We really enjoy this. We enjoyed it, and we continue to enjoy it because we are nowhere near from finished. There's dozens of services in the pipeline that we are going to write, and we will just continue our journey. So to conclude, in the words of the most interesting man in the world, we definitely think the microservices and Node.js have symbiosis. They work really great, and we don't regret our choice so far. Okay, that's it from me.